right, good day everyone. Today I'm going to present on Azure Lake databases. So to save my network, I'll just tap the camera here. Perfect. We'll share my screen. Okay. Usually I will ask if if you can see my screen, but I presume that you can. So let's start the presentation now. All right. So I'm a data engineer slash solution architect because I like to be hands-on. So that's why I'm still doing some development here, but I'm mainly a data architect on Azure Data Platform Solutions. So I did a lot of ETL development on-prem using various tools. I have a lot of data warehouse experience in various domains, like pharmaceutical, finance, insurance, manufacturing, education. I specialize in data warehouses, BI, big data. I wrote several books on data integration like SSIS and Data Factory. I'm the Microsoft Data Platform MVP for the past 14 years, and I co-lead a group in Montreal on data platform technology with Microsoft. So we have a small agenda today, but still, we're going to talk about the data lakehouse and Synapse Lake database, how to use them in our data lakehouse. So the data lakehouse is a natural evolution of data lakes and the data warehouse. You might have heard of those two terms before, data lake and data warehouse. So mid-90s and in the 2000s, we had a lot of projects on data warehouses. And for a good reason, because it was the new kid on the block, and people, we in the 80s or 90s, right? People inserted a lot of data in the databases because relational databases were RTM at that time, right, in the 80s. So now they wanted to get the data out. So to get the data out, the easiest way was to use a data warehouse, to create a data warehouse. So a copy of the data into and for a specific usage. But this has many limitations that I'm going to talk about after. So this is why people say, no, we want something more flexible. So let's create data lakes. So the data warehouse is built with databases most of the time, right? The pros is very well organized. Data is clean, data is validated. It's easy to consume, to query, because it has a simplified data model compared to our sources. Queries usually return in seconds, so sub-seconds. So they are pretty fast because we have many handles to optimize the warehouse, right? It's database, so we have indexes. The optimizer of the database can recognize data warehouses pattern pretty easily. We have partitioning, we have data compression, we have distribution if we talk about Synapse SQL pool. But we have some challenges because when we want to create a simple model that is simple to consume from various the data sources, it requires a great deal of effort to do this data model. And once it's done, we require a lot of data engineering because the source might be complex, but we want to do something simple to consume, right? So to adapt something that is very complex to something very simple might be very time-consuming, and the pipelines might be very complex here. And also, it's schema and write. So schema and write means that we have a schema, right, that we need to fit the data in. So I have a table with 5 columns. It will always have 5 columns, right? If tomorrow I have 6 columns coming up from my sources, I need to modify my table, right? So it's not that easy with the database because now I need to modify the table. I need to modify my pipelines. So this is some limitation that we have here. And also data time limitation. I cannot have my 1 terabyte video in that database, right? It's too big. And also, and for the same reason, If I have 30 years or 40 years of data, I might not store that all in my data warehouse because it would take too much space, and the database will be bloated, and it will impact the performances of my query. So it's not the best place to archive your data. Data lake, on the other hand, are based on files. So those files here can be any size, can be any types. So for the same reason, we can, since it's only disk somewhere that we have in the cloud, right? So we can store a lot of files there. This is the right place to archive the data. Like if we talk about Azure Blob Storage here, or Azure Data Lake Storage, Data Lake Gen 2, we have several type of storage, like the premium, which is the IO optimized, so the one that is very optimized for data intensive queries. But we have also the standard one that comes in 3 flavors, so the hot storage, cold, and archive. So hot storage is the one that we use every day on day-to-day basis. But we can say, you know what, the data that from 5 or 10 years ago, I will put into a cold or an archive storage. So it will cost less. Every time I want to use it, it will take some time to rehydrate, which means that we need to bring it out from the vault and bring it to our data lake to be able to consume that. But on the long term, it will cost less, right? So it's file-based. So if I have a Kafka client that want to write data to my storage account, that's easy. They can do it. They don't have any specific schema to comply with. Like if I can have various schemas in the same folders, we don't care about that. I cannot have various schemas in table, right? Unless I'm using semi-structures like JSON or XML. But the challenges here is that the queries are written in seconds. They are not as fast as a database, right? And we don't have a lot of handles when it comes to performance tuning. It's mainly via partitioning. We can use the Delta Lake that has a better compression and help us with the file skipping here, or we can use the Z ordering with technologies like Databricks. So the consistency also will vary, right? Because the data might not be clean at some point. It's files that have been dumped there, and we don't clean that data. We might not clean that data, but the usage is different, right? Because we want to use data lakes to do data science sometimes, and data science, they want to have access to the raw data. This is the right place to do it, right? So it's schema-only, so it's harder to query, especially when I have a lot of files and different structure. So it might be, and it's harder to query compared to an optimized relational model for sure. So data lakehouse combined the pros of the both previous architecture, right? Data lake. So we have storage and data type flexibility, schema type, and schema 2. Give access to various types of data. I can have my 1 terabyte video there. I can have multiple 1 terabyte video there if I want to, because the storage is almost unlimited. And on top of it, I can create a data warehouse, and which has optimized data model that is easier to query, and data has been cleaned and validated. So to get started with data lakehouse, basically, I don't need to create a data warehouse up front like we were doing 15 years ago, right? What I'm going to do, I'm going to create a data lake first. And in the lake, I'm going to organize it. I'm going to show you the next slide, how the architecture of data lakehouse. So I will create data lake first. Now, when I need cleaner tables, I need to clean those tables and put them into another layer. And then after that, once those tables when I have a lot of clean tables, I can integrate them into a data warehouse if needed. So this is the lakehouse architectures. I have my sources here, which is databases, files, streaming data like Kafka, Event Stream Analytics here. I will ingest them into the raw, which is the bronze, which is the data is ingested as is. I don't do anything. I just ingest the data, disconnect from the source as soon as possible. Then in the silver zone, this is if I do data science, I will connect to here. So a lot of data scientists like to work with the raw data. But here, if I want to consume this data to be more consumable, I would say, I will try to validate this data here using validation mechanisms and reject the bad data. So here comes the silver zone. The data is validated and clean. Might not be ready to consume. I might not have an optimized data model. So this is where the gold comes in here. The goal in some implementation the might be a database, right? So some patient might have those 3 layers in the data lake, and the goal might be the database layer. So now, Azure Synapse Lake Database, let's talk about them. So these are the concepts here, right? We browse the database templates. We can create custom too. I'm going to show you that later in my demo. We can visually create lake database. We have a designer that I'm going to talk a lot in the next few slides here. And we have here, we can load this table using pipeline data flow. We can also use Spark notebooks, and we can also consume the data using SQL pools, Spark, and Power BI, machine learning, and whatnot. And the storage is Spark or CSV. So they are useful for both developers and consumer to understand what we have into the data lakehouse, right? What are those structures? How are they related? So the supported file format, as I mentioned before, CSV Parquet. Data platform MVP like me scream to have the Delta format available here, but it's not there yet at the time of this demo. When you're going to see this demo, maybe the Delta format will be there. We never know. And now we can model using if we're using a graphical designer like Yawin, Power Designer, and whatnot. So we have primary keys, we have foreign keys, relationship. We can have partitioning. We can decide what partition columns are we using here. And we can have metadata on top of it, so descriptions. Also, table expo to Snap Compute services like serverless pool and Spark, mapping data flows, Spark pools. So we can consume the data using that. So how do we design a lake database? So we can start from scratch. So we create an empty table and define its structure. We can use files that we have in our data lake, or we can use database templates. These are predefined schemas, right? So I'm going to show you that later. We have a lot of structure, and they can be customized to fit our needs. Talking about that, let's do a demo now. So let me go to here. This is not what I want to show you, but this is an example of the design that we have. Let's create a new lake database. We can create as many as we want. So DPS demo, that's fine. And I would choose Parquet, but this is mainly an indicator. I'm not constrained by the Parquet file. I can have CSV tables if I want to. So now let's create a custom table. Okay, let's call it customer account, right? So because I'm lazy, so I will copy it. Right now, the storage settings here, I can inherit from the default, which is Parquet. But as I just mentioned, I can also use delimited text. Now I choose the settings for my text. Here, is it comma? Is it delimit? Is it tab? Is it pipe? So I can do it, and I can choose the quote character. For now, we'll use the default, which is Parquet. Here, perfect. Data compression, I can use Snappy, gzip for now, I'm going to use none. Now I will have my primary key here. Here, perfect. And this is going to be an integer. Let's add a new column here called typing, but sometimes it happens. Name, which is a string. I can have a description if I want to, which is a string here. Perfect. And remove this here. Yeah, the string will be one with characters. So let's keep that table like that for now. So this is my table. I could have created also a partition column. So I could have say year, month, and day, right? I could create 3 columns for my partitions. Now let's bring a table from the templates. What's nice about those templates is that I can browse the template without adding it to my model. So here, we see I click on automotive here. I have a lot of, I can go to policy, I can edit inventory, I can go to product, I can go to order. Let's go to order here, and let's go to invoice. Let's bring the invoice here. Okay, now I have a lot of columns here that I might not want to have all of them, right? So I want the invoice ID, customer account ID, invoice date, invoice to name, I don't need it, to party ID. So we'll bring a lot of columns here. Yeah, and maybe why not here? Yeah, let's keep that. Let's remove this here. Perfect. Okay, so this is the table that I customized. Now let's add it to my model. Now it's there. Perfect. Now what I'm going to do, we need to relay those tables together, right? Customer account ID with customer account ID. So I can do it. You have 2 ways to do it. I can do it from that table here. You can see relationships to customer account. So to table, take it from the invoice table. Is the invoice, no, customer account ID, not the invoice ID, and link it to my primary key, right? Now I have a data type mismatch here. So I can go here. Okay, it is short. This one is short. I go here, right? You see? No, this is a long one. Okay, then I can convert it to integer. I can customize it. Now if I go to relationships, now I see from the front because I switch table, I don't have any warning. So this designer will help me to validate my model too at the same time. Now I added a column from the table from the templates. Let's add a column from the lake. Abbreviation here. I choose my storage account, that one that is linked to Synapse. And let's go to my root folder. I want to create it from the branch. In the branch, I have 3 folders. Let's use state abbreviation. Continue is going to look at all the files I have inside of it. I have only one. But if I have many files, it will parse all the files. I can do a preview data. I don't have any column names. But if I had column names, I could say infer column names. Preview data. You see? For this data set, it doesn't make sense. So I'm going to remove this. And let's create it. Now I go here. I say abbreviation here and state name. Now I'm going to say 10 characters for a state abbreviation is more than enough, and 100 characters here. So here I would not do any relationship on top of it, but just to show you that I have those 3 types of table that I can use. And I have this navigator here that is quite useful if I have a large model. I can remove it if I don't want to. So if it's annoying, you can remove it. Now, the table that comes from the template has been stored into a folder, right? The folders are read-only. That's a caveat that I don't like because I would like to be able to create my table into its own folder. But you see that the data is formatted, so it's Parquet here, but this is as much as I can do here. So you see this folder is other. I cannot change it. Maybe it will be an improvement that we can have in the future, but for now it's not available. So this is the three type of tables. Now to see this model, to make it available, because you see I have my Lake database, but it's not published yet. I can see my tables here. I can see the columns of my tables and their data type. But now to make it available to other consumers like Power BI, like Mapping Data Flow, I need to publish it. Yeah. I have error here. You see, customer ID in invoice table, and customer ID in account table. So it validated for me. So if I go here, it's integer. And the other one here is, here, let's go here, columns, integer 2. So I don't understand why it's complaining, but it's not working. Check. Just want to see the error again. Could I send the type? It's like it hasn't recognized my data type here. Yeah, both integer, but for some reason it doesn't like it. Anyway, this is not. This is a small bug maybe that they have here, but because it's integer in both tables, so that should work. I had this error before with strings here, so that I can understand. Because the customer account ID is integer too, so that should work. Anyway, if I go here to my database here, the one that I did before, so this table here is the state abbreviation table that I just showed you that I imported in my demo. And then after that, we have the census population count by county here. This is the table that I imported from the data set that we have with Synapse. If I go to here, the North Center, Browse Gallery, data sets, go to population by county. Here, so this is what we have, right? This is the one that I brought. State name, you see the state name is just the name of the state here, and so on. So I added this. I did it before, so I would not do it again. So I can see it here in my link services. This is the one here. So this is exactly what I was showing you. It contains 2 years, so 2000 and 2010. And it contains, if I do a count here, something like 3 million rows. Yeah, almost 4 million rows. So this is the script here. And the other one that I'm using, this is something that I found on the web, is the yeah. Just remove this, perfect. State tax information. This is a huge table, quite huge. It contains a lot of columns, right? I'm only interested in 2 values here, the state column here, and I want to use the N0 to 60 here, so 6650. This is the revenue that people have put into their taxes every year that they send to the government. So this is the one that I want to use. So, but here I imported all the columns here. That's okay. What's nice about it is that this table is already part of my lake. What I can do, just move this one. I can see state tax information. Picked up one of the rows and I can query it, and you see all of the columns here and all of the information. If I can do a count on this, it's not that big. Count. Here you see only 27,000. So it's only for 1 year, which is 2017. I know the year that they don't match, but I just wanted to show you what we can do, how we can play with these tables. Now, if I go to check, that's fine. So if I do, well, okay, I click on run again. Doesn't like. Okay, because I highlighted the query. You see, I have the state abbreviation here. I have the right thing here. So I can do a join with my state abbreviation table, which is this one here that I showed before. Right? So I can do a join directly using that. Yeah. The reason why I bring this is because I don't have in the other table here, I don't need the state name. So I want to get the state abbreviation to link those two table together. So what I want to do, now let me go back to the model. We close this here. Now, this is my target table. It's the join between those county and the tax info here because it's census position county and tax information. Yeah, so what I did, I simply created those columns here. Yeah, the string here is 10 and the other one is 100. It's fine. And then after that, I created the relationships, as you can see here. So all the relationships are created. So this is the target table. So this is what we can do with the design. I had some hiccups tonight for some reason, but usually it's working well. Right? So let's go back to the presentation. So now, how can we integrate data? How can we load those tables? Right? We have two ways. We can use Synapse pipeline, mapping data flows, or we can use Spark Pool. So I can insert the data into those tables using the Spark Pool, maybe Notebook or Spark Job. So it depends what I want to do. So now let's see how we can do it. Let's go back here. All right. So now I have this guy here. Usually I can click on that here. I think and then I can select Azure Data Lake Storage Gen 2 or Lake Database. Where are my source, right? And the database, I will choose this one here. Take all of them. And now the name of it, DFT But then I have a problem tonight with my cluster here because my runtime, because it doesn't work well. I always have some errors. Well, that's quite easy. I have an error here. But I did before. It was working. It's a wizard basically that helps you to build your transformations. Would have loved to show you how it worked though. But if I go to my pipeline here, I have two pipelines. The main, this one has been created by the wizard. And we call another pipeline that contains a data flow. So if you remember the model here, 1, 2, 3. So these are my, if I go back to my Lake demo, those three tables, right? They are my source and this is my target. And if I go to my data flow here, they are all in the workspace DB, right? Because when I have three choices, right? In the data factory, I have only two. Integration data and inline. In that case, in Synapse, we have workspace DB. So it's a table for my workspace DB here. And the database is Lake here, Lake demo. And the table is state abbreviation. Lake.lake demo here. And the thing I use a cache lookup because I have only 51 rows here. So basically, you remember I have the state name. I want to have the state abbreviation. What I'm doing here, I'm going to say, give me the state name, and I will give you the state abbreviation that comes with it. Because this thing has only two columns, abbreviation and name. Right now, I take the tax information. This is the one that had a lot of columns and 3 or 4 million rows, right? So I just need to have to select a few columns here. So I did the select here, and I was able to take the state and this guy. Let me see if the cluster will work here now. I might be in luck. No, we have some problem here. Okay, but this is basically the data that I just showed you using the serverless tool. Now we'll aggregate by state. So give me that famous column. So A0250, that was N is A here, and aggregate it here by state, basically. In that case, it would be state name, right? So then after that, I'm going to publish it as long here. And then I'm going to put into a cache, because now I went for 4 million rows to something like 51 rows. So I brought it to my cache here. Now, when this is done, I will click here. Now this is my third source, which comes from what I brought, I think this guy here. No, the dear one. Anyway, this is the one that comes from. I think I closed it. Yeah, that's fine. This is the one that comes from the samples, right? I have the state name here. So let me go back to my data flow task. All right. And this is my census table, which has a few columns. I'm going to filter. We have 2000 and 2010. So I'm going to filter that only on 2010 because I don't want to repeat the values, since I have only 1 year on value with my state tax information. So I'm going to get the abbreviation because I have the name here. So for that, I'm going to use my sync cache lookup, and the sync cache lookup, if that works, I should see the states here, the state abbreviation. So I'm saying, I give you the state name, right? Yeah, say I have a problem with my cluster, and give me the abbreviation, right? And after that, we need to aggregate using the abbreviation, the state name, because I want to use it in my sync, and the additional time here, which is the year. And I'm going to sum of the population. Here I did the sum. I did the sum of the revenue. I'm doing the sum of the population here by state. Now, since I went for 4 million rows to 51 rows here, I can easily do a cache lookup. See, now this time I say, you know what? I'll pass you the state abbreviation and give me back the state revenue here. And I would push it into my sync. My sync is a workspace DB. And this is my Lake database. You see, I could have chosen the DPS demo. It published it for some reason. Anyway, but I could have used but I'm using my Lake demo here. And then this is my table. And I have not a lot of options here. None, which is append, or recreate table. So I don't have a lot of options. It's a Parquet file, right? So, and I don't have any error. I didn't use the errors tab here. So, and now I do my mapping. So at the end of the day, I think this thing will work, but we'll try. Should be able to see the data that has been, because I ran it before. Yeah, I have the same problem here. I need to restart my data flow debug here. So since it takes 5-10 minutes to have it, I will not do it, but I did it before. So now I can query this table that I already loaded. I don't have a lot of rows inside of it, right? So this is basically my tax year, the review of the population count here. So from 2 sources and using a mapping table, which is the state abbreviation, I was able to link those tables together as I showed here. And I have too many things open now. Close this. Yeah, close it. Changes here. Perfect. This one don't need it. We get my Lake DB and just open. Perfect. So from those 2 tables, I linked them using the state abbreviation. I was able to create this table. It's a simple pipeline, but this is something that showed the power of this, because I was able to see the columns, right? I didn't have to do a query like I did just to see the columns. The query to see the values, but when you try to see what colors I have, it's harder to see here than if I go to my designer here. And then I can say, you know what, let's go here and let's see what color I have, right? So it's much easier to do it here. And I can filter my column here. So A0250, this is the content that I use here, right? So this is the power of that tool. It's very nice. I think they have a bit more work to do, right? Because right now it's only work with a few format. And what I'd like to do is to be able to export this schema here to a PDF file. So we'll be able to share it with someone else and be able, like we had with other tools, to see the data types here. So have a detailed designer as well as a simple view like this one here. Right, so let me go back to the presentation from the current slide. Right, oh, a bit too fast. Let me go back here. All right, so we can load it using mapping data as I showed you before, and we can use the Spark jobs. Also, we can see the data here. So let me go back to my workspace. What I want to show you is that if I use this guy here, I can say, I can do a query, or I can use it into a notebook, right? So in it, it's going to query the Lake Demo DB, so because it knows where it is, that census population county. A bit like we are doing with the data lake. For those who use the Delta Lake, we're doing something similar to that, right? This character is here. So I don't have any Spark pool, but this is something that can be done. So, and I can also insert data here. So that's done. Let me close it. Closing this card, change it. I don't need it. I want to report on that too, right? So if I want to report, I'm going to get data from choose more. We'll say Synapse. Now you see that I have Synapse SQL, which is the SQL pool, and I have the analytics workspace beta. I can choose it. It's still beta. It's not GA yet. And now I can go to all my Lake database that I have. I can go to Lake Demo here, and I can say, give me this table here. Then I could do a report. So I can do that from any tables here. So I can do a report using Power BI very easily here, just like those that table here for some reason, and can click load. I could transform the data. Now it's going to bring my table here. For him now, it's not a file, it's a table. So waiting, creating the connection in the model. And we should have it one day. Always take longer time when you present. Yeah, perfect. Yeah, it's bringing, it's importing the data now. Yeah. So anyway, I can do report from Power BI. So report from Power BI. Go back here. Right. So to sum up, data lake houses combine both the best of the both paradigm that we had before, which is data lakes and data warehouse. Azure Synapse Lake database templates are very good, and the design are very good to standardize our data lakehouse, right? It helps us to have standard column names, standard data types here. Data pipelines, I showed you some transformation that I did, but we have a lot more transformation that we have into the Synapse data pipeline, which is data factory pipelines underneath. And we can use Power BI to connect the workspace and database. It's still in beta state, but it's still, but this is something that will be GA one day, and we'll be able to connect to this workspace DB. Now, I will be available here if you have any questions. So otherwise, thank you very much. It was a pleasure for me to present about Lake databases. Thank you.